Right, my dear children? So now let's see what are these magnetic materials and what are the non-magnetic materials. So in this activity, we are going to find out what are the things which are getting attracted towards a magnet, or else what are the magnetic materials, what kind of things which shows the magnetic properties. And the other thing is the other type of material is what kind of a material or what sort of a material which do not attract to a magnet. So these materials are referred as non-magnetic materials. So now we are going to identify what are magnetic materials and what are non-magnetic materials. So I have several materials in here. I have a stone, an iron nail, a plastic ruler, then some coins, and a brass nail, right? So these are the materials that I have. So I have some coins, a stone, an iron nail, a brass nail, and a plastic ruler. So these are the materials that I have. Now what I am going to do is, I have a magnet which hung on a stand in here. So this is my magnet. So now what I am going to do is, I am going to take one of these materials. Towards the magnet and see whether that material is going to attract towards the magnet or not. So let's conduct the activity and see whether the materials are getting attracted towards the magnet or not. So I have this coin. Now I'm going to take this coin near the magnet and we'll see whether it is getting attracted towards the magnet or not. So let's see. So you can see that the coin is getting attracted to the magnet and it's keeping steady without falling to the ground. So this coin is a magnetic material. So I'm going to remove it. I keep it in this near to the magnet. I'll keep it in here. So these are the materials which are getting attracted to the magnet. Then I'll use the other coin. This is a 1 rupee coin. The earlier one was a 10 rupee coin. So this is a 1 rupee coin, smaller 1 rupee coin. Then I'm going to take this one near the magnet. We'll see. So the 1 rupee coin also attract towards the magnet, right? So the coins are getting attracted towards the magnet. So we can say that the coins are magnetic materials, right? Then, so coin goes to here, magnetic materials. Then I'm going to take the stone. So this is the stone. Now I'm going to take the stone near the magnet and we'll see whether it is getting attracted or not. So you can see that it's not getting attracted to the magnet. So stone is not a material that has magnetic properties. We can't attract a stone towards a magnet. So stone, I'll keep it in here. Then I'm going to take this iron nail. So you can see the iron nail. So we'll see whether the iron nail has magnetic properties or not. So you can see here the iron nail is getting attracted towards the magnet. So it's keeping steady without falling to the ground because the magnet attracts the iron nail. So iron nail has magnetic properties, right? So I'm going to keep the iron nail in here as it shows magnetic properties. Now I have a brass nail. So this is an alloy. Alloy means it's made up with two types of materials. It's a metal but made up of two types of materials. Now in brass we use zinc and copper, and together zinc and copper, right? When you mix together zinc and copper, we can create the material, or we can create the metal called brass. So this is a iron nail. This is an iron nail which is made up of brass. So we'll see whether the brass is going to show magnetic properties or not. So you can see that the brass nail is not getting attracted towards the magnet, even though it is a type of a metal. See, even though it is a type of a metal, but it is not getting attracted towards the magnet. I'll take the iron nail and I'll show the difference between the brass nail and the iron nail. So this is the iron nail. So iron nail is steadily getting attracted towards the magnet. So there is no trouble in identifying as the iron nail as a magnetic material. So now see this one, the brass nail. So even though brass nail is getting contacted with the magnet, there is no attraction. See, there is no attraction. If I am going to release my hand, see, you can see that the brass nail is going to fall down. Means that brass is not a material which show magnetic properties. Brass is not a material which show magnetic properties. So even though it is a metal, it's not a magnetic material. So I can remove it to here, as it is not showing any magnetic properties. Now the final one, the plastic ruler. So I'll take the plastic ruler and bring it near the magnet. So like in the stone and in the brass nail also, the ruler is also not getting attracted to the magnet. So we can say that the ruler is also, or the plastic ruler is also a type of a non-magnetic material. So I'll keep it in here. So my dear children, we can see that there are some materials which show magnetic properties. These are those types of materials, some coins and an iron nail. And there are some materials which do not show magnetic properties. So these are the materials which show magnetic properties, means that these materials are getting attracted towards the magnet, iron nail and the coin, right? And these are the materials which do not show magnetic properties: a stone, a brass nail and a plastic ruler, right? So these are the types of magnetic and non-magnetic materials. So we'll find out even more things which show the magnetic and non-magnetic materials when we are discussing the further things related to the lesson, right, my dear children? So now we are going to investigate whether the magnetic power or the magnetism in a magnet evenly spreads or not. Means that we are going to identify the poles of a magnet. So let's see, if you take a magnet like this, now this is called as a bar magnet. This is called as a bar magnet, this one. So you can observe there are two terminals. This terminal or this end, it has a red color, and this end, it has a blue color. And here the blue end is marked with capital S and the red end is marked with capital N. Means that these are the two poles. These are the two poles of a magnet, right? The two poles of a magnet, right? The North Pole and the South Pole, the two poles of a magnet. So what are the magnetic poles? So what kind of things are the ones which are called as these poles? So magnetic poles are the things which has the most magnetic power. So here we are going to investigate that a magnet has more strength on their poles. So here I am going to take another bar magnet like this. So you can observe that this bar magnet, I have covered it by using a polythene cover. See, it's because that now I'm going to drop some iron fillings into it. I'm going to drop some iron fillings into it so that to identify the more powerful area in the magnet. So the thing is that if I'm going to use a naked magnet like this, and when I'm going to drop some iron fillings, right? So it would be hard to remove those iron fillings from this magnet once again. So that's why I have covered this thing by using a polythene cover so that I can remove the iron fillings very well. Iron fillings or iron powder can be removed very easily if I'm going to cover this thing by using a polythene wrap. So now what I'm going to do is I'm going to take some iron powder. This is called iron powder or iron fillings. So I'm going to use these iron fillings and I'm going to spread on this A4 sheet like this, right? Need to spread it. So I'll use a glass light to spread this thing here and there. So I'm going to spread this thing like this on the surface of the paper. On the surface of the paper, I have spread the iron fillings or the iron powder. Right. Now what I'm going to do is, I'm going to take my magnet. I'm going to take my magnet and place it on this like this, and I'm going to tap gently like this so that the powder would attract to the magnet, right? Okay. Now you can clearly see that more amount of powder, iron powder, is attracted towards the end. See, if I am going to take this one to far like this, so observe at the two ends we can observe large number of iron powder. See, at the two ends we can observe more amount of iron powder. It's because that at the two ends of a bar magnet we can observe the most or the highest magnetic power. So these ends or these areas which has the highest magnetic power in any kind of a magnet are called as magnetic poles. So in a bar magnet we can observe the magnetic poles at the two ends of it. These two ends are the ones which are referred as, or these two poles are the ones which are referred as the North Pole and the South Pole. More often we use the red color to indicate the North Pole and South Pole being indicated by blue color. So in this activity it's obvious to us that in a bar magnet, the magnetic poles are located at the two ends or at the terminals of the magnet, and also at the poles we can observe the highest magnetic power or the highest magnetism. Now I told you that it's not easy to remove this iron powder. So see, it's not easy to remove iron powder. Even though it is covered with a polythene wrap, it's really hard to remove this iron powder. No matter how much I'm going to try, I can't remove all of these things. 100% of iron powder cannot be removed from this magnet because it is really difficult to remove these things. So that's why it's not good to use a naked magnet like this, right? So if you use a naked magnet like this, then it would be hard to remove these magnets, and it would be hard to remove these iron fillings, and you have to remove this magnet. You can't use it. So that's why we are covering this magnet by using a polythene cover so that we can easily remove these iron fillings from the magnet. When I'm going to remove this polythene strap, I can remove the iron fillings quite easily. So this is all about with the magnetic poles then. So remember, in a bar magnet, when you take a bar magnet, the magnetic poles are located at the two terminals, and the most magnetic power could be observed at the two terminals in a bar magnet. Right, my dear children? Now, let's see how to find out the poles of a magnet. So, here we are going to find out poles of a magnet by using, this instrument is called the compass. So we can use a compass to find out the poles of a magnet. So here I have a bar magnet. And the compass. So I'm going to show you how we can use this compass to identify the poles of a bar magnet. So here you can see that the poles of the terminals or the two ends of the compass is showing north and south directions. So always a compass is going to turn for the north and south directions. If I am going to freely suspend this compass, or if I'm going to if I'm going to keep this compass on a free position like this. So now let's see. Here in the compass you can observe, in this compass here you can observe the red color. That means this is the north, and the other terminal then it is the south. So you know that in a compass we use a free rotating magnet. In a compass we use a free rotating magnet, right? So this is also a magnetic material. So we'll keep it like in here, and let's see how to identify the poles of a magnet. So now I have a bar magnet with me, and you can see this is the south pole, this is the south pole, and here you can observe this one is the north pole. Now what I'm going to do is I'm going to take this compass and bring near the south pole of this magnet towards the compass. Let's see what ends of the compass, or which end of the compass is going to attract towards the south pole. So let's see. So you can see that clearly, you can clearly observe it, right? When I'm keeping in this way or in this position, here this is the south pole, this is the south pole. South pole is attracting towards the red color terminal of the compass, means the north pole, right? So we can use this compass to identify the terminals or the poles of a magnet. Now if I'm going to interchange the two terminals, means that I'm going to now take the north pole. I'm going to take the north pole, right? I'm going to take the north pole towards this compass. You know that compass is also a magnet. So if I am going to bring near the magnet near the compass like this, right? The compass needle will change. See, it's rotating here and there. See, it's because that compass is a magnet. So direction of the compass can be changed, or direction of the compass is getting changed when a magnetic field or when a magnetism is around, or when the magnetism is near the compass. See, so that's why I take this thing somewhat far. So here this is my north pole. Then now I'm going to take this north pole towards the compass. We'll see what's going to happen. And now here you can observe that the south pole or the terminal which do not show the red color is getting attracted towards the north pole of the bar magnet. So we can come into conclusion that if you take any kind of a magnet and a compass, we can identify the magnetic poles. We can identify the magnetic poles. Only thing that we need to do is we need to take the magnet near the compass. So always remember, in a magnet, in two different magnets, unlike poles are the ones which are getting attracted each other. Unlike poles are always getting attracted each other in two magnets. So when I'm going to take this magnet near the compass, the opposite poles would attract. Opposite poles would attract. Here you can see that compass needle that do not show any color, or that haven't colored with the red one, is getting attracted towards the red color of this thing. And when I'm going to interchange, see, when I'm going to interchange, the blue color area or the blue color terminal is getting attracted towards the red color region of the compass. So by using this observation, we can find out the poles of a magnet. Right, my dear children? Now I have a magnet. See, I have a magnet. Here the terminals cannot be observed. Means that this magnet is a magnet that has unknown poles. So by using the earlier situation, or by using the earlier observation which we took when we took a bar magnet near this compass, so by using that earlier observation, we could find out the poles of these two poles of the magnet given in here. So now what I'm going to do is, I'm going to take this magnet and I'm going to bring it closer towards the compass. So you can see that, see, it's clear to us. It's very clear to us. Here this terminal is getting attracted towards the area or towards the end that do not show the color. So the terminal of the compass which do not show that color is the south pole. This terminal is the south pole. So you can see that south pole is attracting towards the terminal or the end of the magnet in here. So I can conclude that if this terminal is the south pole, if that south pole is attracting towards this terminal, means that definitely this terminal should be a north pole. See, this terminal is the north pole then. This is the north pole. If this is the north pole, this other terminal, that's the south pole. So to make our conclusions, or to make our conclusions more accurate, I'll take this end towards the compass, and definitely this end should be attracted, or this end is going to attract the red color terminal of the compass. So we'll see whether this terminal can attract that red color terminal of the compass. So I'm going to take, so this is my compass now. So I have taken the other end now in my magnet. Now I'm going to take it towards the compass. See, you can see clearly the red color terminal is attracting towards the pole of the magnet. So this pole is the south pole. So this is the south pole. If I'm going to interchange it, and bring near, then the other terminal of the compass is getting attracted towards the unknown magnet. So this terminal then, that is the north pole. This terminal, that is the south pole. So this is how we can identify poles of an unknown magnet by using the compass. Right, my dear children. Now let us find out another way in identifying the poles of a magnet which are unknown. So here you can observe a magnet with unknown poles. So I have hung that magnet by using a thread on a wooden stand. See, this is a wooden stand. By tapping you can observe it. This is a wooden stand. It's not made up with metal. Why it is important to use a wooden stand is, so here if I am going to use a material made up with a magnetic material like a metal, so the magnet will attract towards this thing or towards the stand. So in that kind of situation we can't get the observations or the desired observations very accurately. So it's wise to use a wooden stand like this when we are conducting experiments related to magnets. So now let's identify a special feature regarding the magnets. So now I have a magnet which hung freely, and also I have a compass with my hand. So you can see when you observe this compass, now the compass needle is pointing, the red color needle is pointing that direction, means it's the north direction of our earth. So here you can observe the compass needle. So the compass needle is pointing towards the north. So this is the north direction of our earth. That direction is the north then. That direction is the north. So I'm going to keep the compass like in the same way, right? Then this is my magnet. This is the magnet which hung freely, right? So now I'm going to hold it in my hand. So I'm holding it in my hand. So now I'm going to release it. Let's see to which direction does the two terminals turn. So now I have released it. So it's rotating here and there. So here, so I have given a small bit of a push, and now it's rotating here and there. Let's see at which end or to which direction does this magnet going to finish its rotation. Right now, my dear children, you can observe that the rotation of the magnet has stopped, and you can observe this terminal of the magnet is pointing that direction, and same as the pointer of the red color pointer of the compass is also pointing that direction. So it's obvious to us this terminal of the magnet should be the north terminal and the other one is the south. It's because that when you keep a free suspend magnet like this, always the two terminals are pointing, or they would align in north and south directions of our earth, like in the compass. So here when you take the compass, you can observe the compass needle is always pointing towards the north and south directions. So that's a common property in magnets. If you hung a magnet freely in our environment like this, always the two terminals is going to show the north and south directions. So the terminal which turns towards the north is the north pole, and the terminal which turns towards the south is the south pole. So by using the compass also we can conclude our observations. So this pointer is showing the north direction, and this point is also showing the known direction. So this terminal is the north and the other terminal is the south. So by that way, we can conclude the two terminals of a magnet that has unknown poles by hanging it or by releasing it in the environment like this way. Now by hanging it by using a thread, we can identify the two terminals of a, or identify the two poles of a magnet by hanging it like this. Right, my dear children. Now let us investigate another method how to find out the poles of this unknown magnet in here. So this magnet also, an unknown magnet, means that we don't know the poles of this one. So by using another method, now in here also we're going to freely suspend this magnet, but I'm not going to hang it, but I'm going to float it in this water basket. Now you know that when a magnet is freely hung or freely rotated, it's going to turn to north and south directions. You know that. So I have a compass in here. So you know that if you take the compass, always the two terminals of the compass, the needles of the compass is going to turn to north and south directions, as it is also a type of a magnet which pivoted freely on this metal or the steel case. So here you can clearly observe that direction is the north and this direction is the south. That direction is the north and the opposite direction is the south. So red color pointer is pointing towards the north. So I'm going to keep the magnet, keep the compass in this position like this. Now I'm going to take my unknown magnet. So instead of, so I have used a styrofoam or else a rigiform board so that I can keep the magnet without sinking in this water basket. So now what I'm going to do is I'm going to place this magnet on the water basket, and let's see whether the two terminals is going to show north and south directions. So I'll take it to the middle once again. So it will float and eventually will turn to north and south directions. So I'll take once again towards the, keep it in like this kind of a position, and let's see whether it's getting turned towards the north and south directions. Okay. Right. So my dear children, I have turned the magnet to this kind of a direction, and still it turns this kind of a direction and always pointing towards that direction. And you can observe when you take the compass needle is also pointing that direction, and this terminal of the magnet is also pointing that direction. So means that it's quite obvious to us, this terminal which turned towards the north direction of our earth, so this terminal is the north pole, and the terminal which turned towards the south direction, this way around, is the south pole of the unknown magnet. So each and every magnet which rotates freely or which hung freely in our environment ultimately turn towards north and south directions. So by using that property, we have found out the poles of this unknown magnet. So here we use a water basket and we float and we float the magnet by using a styrofoam board or else a rigiform board. So this is how to identify the poles of a magnet by floating it in water. So let us investigate another method in finding out the poles of an unknown magnet. Right, my dear children. Now let's find out another way of finding out the poles of a unknown magnet like this. So once again I have hung the magnet, the poles with unknown, the magnet with unknown poles. See this magnet, I have hung it by using a thread on this wooden stand, right? So let's identify how or what are the north and south poles of this unknown magnet. So now in this situation, I am going to use another magnet. Now in this magnet, we know what are the north and south poles. So the area which colored with red color is the north pole, and the area which colored from blue is the south pole. Right, my dear children? Now let's see, or let's observe whether the above statement is true or not. So I'm going to take another magnet and I'm going to show you that the north pole and the north pole, or else the south pole and the south pole, means the like poles are going to repel each other, and the unlike poles like north south and south north are going to attract each other. So I'm going to take another magnet and we'll see whether the above statements are true or not. So I have another magnet here, the second magnet. Now I'm going to take this south pole towards the south pole of this magnet. So it's clear to us that there is no attraction, right? There is no attraction. Now I can feel it in my arm. They are repelling each other, right? See here, they repel each other. See, can you see that? They repel each other. The magnet will easily rotate to the other side. See, can you see that? So now I am going to take this red color terminal towards this blue color terminal, and let's see whether it is getting attracted or not. So it's clear to us that these two are getting attracted quite easily. See, if I am going to take the other terminal, the north terminal towards the north terminal, once again, see, those two terminals are getting repelled each other. See, so always you can observe the unlike poles are getting attracted each other, and the like poles, they would repel each other. See, they are like unlike poles are always, these poles are always repel each other. You can observe it. And now by using that feature, right, we are going to find out. Now I'm going to keep this other magnet, the second magnet, away. Now I'm going to have this magnet and bring this south pole towards one terminal of this unknown magnet. So if that terminal is getting attracted to the south pole, then that attracted terminal of the unknown magnet is the north pole. When I'm going to take this north pole towards the one terminal of the unknown magnet, if it is going to repel each other, then that terminal is also a south pole. So by using that feature, let us find out the poles of this unknown magnet. Okay, now I am going to take this magnet, the south pole of the magnet, towards the now see here, you can observe the south pole is getting attracted towards this terminal. Means that this terminal which is attracted towards the known magnet should be the north pole. So this is the north pole of the unknown magnet. So if this terminal is the north pole, then the other terminal, this one, is the south pole. So let us conclude that pole as the south by interchanging the two terminals of the known magnet. So let's interchange and see whether the other pole is getting attracted towards the red area. So I'll keep my finger like this. So this is the other end. This is the end which attracted towards the south pole, this one. See, once again you can observe it. So I'll keep my finger like this. And now I'm going to take the red terminal, the north pole. And now let's see which terminal is getting attracted. See? So a magnet rotates and turned away, then once again it came back and the other terminal got attracted. So it's clear to us. We can identify the two terminals of this magnet by using this known magnet. So by the attraction and by the repulsion of the known magnet with the unknown magnet, we can identify the two terminals of this unknown magnet. So if the north pole is attracting, towards one pole, then that pole is the south of the unknown magnet. And if the south pole is getting attracted to this magnet, to a certain pole of a magnet, pole of this magnet, then that pole is the north pole of this unknown magnet. So by using that simple attraction theory, we can find out the poles of this unknown magnet. So we'll find out another way in finding out the poles of this unknown magnet by using a different way, by using another way. Right, my dear children? Then we'll observe another method, or we'll conduct another activity to find out the poles of a unknown magnet like this. So here also we going to freely suspend this magnet, but in this occasion we use a watch glass. So watch glass is a glass made like this, right? This is the one which is referred as the watch glass. So it has a concave and a convex shape. This is a concave one and this is the convex shape. So now what I'm going to do is I'm going to take another watch glass like this, which is held inverted, and I'm going to place it, the second watch glass, like this, so that it would rotate around second watch glass quite easily. See, so it's rotating around the second watch glass quite easily. And now I have a magnet which we don't know the poles. See, this is the magnet which we don't know the poles, and now I'm going to place it on this watch glass. Right, now let's see another time whether the expected observation could be observed or not. So I have placed the magnet like this. So let's see whether it is getting turned towards the desired direction or not. So once again you can see the magnet which placed on the watch glass has turned to this direction, and also I have a compass in here. So you can see the compass needle is also pointing towards that direction. So means that here you can observe the red color of the compass. So it's showing the north direction, and this terminal also pointing towards that direction, which is same as the north direction of our compass. Means this terminal which turned towards that red color region of the compass should be the north terminal. So you can take a small bit of a sticker or else a paint, and we can put a paint like this. So this is my north pole of the magnet. So I'm going to place it again so that you can observe the turn in direction very clearly. See, always the north pole is going to turn towards the north direction, same as the compass. So this is my north pole of the magnet and the opposite pole is the south pole. So these are the ways of identifying magnetic poles if the poles are not marked on this magnet. So this magnet is a magnet that has unknown poles. So we discussed several ways in finding out the poles of this unknown magnet. Let us further discuss what are the things which are related to our lesson then. Right, my dear children. Now in this activity, we'll be finding out the area which the magnetism is going to spread. Right? Like to what kind of a area we can observe the magnetic power or the magnetism in this bar magnet. So let us investigate the area which the magnetism is going to spread in this activity. So here we'll be needing these things, a bar magnet and a white color paper and some iron fillings or some iron powder. So now what we have to do is, I'm going to take this A4 sheet and first of all I'm going to add some iron fillings into this paper, right? I'm going to spread iron powder into this paper like this. So I need to distribute iron powder here and there all over the paper, right? Now after spreading all these iron fillings on the paper evenly, right? So now I'm going to place this magnet. Now I have a magnet. Now I'm going to place this magnet not from the top. Remember, you can't keep it from the top. If you keep it on the top, then all these iron powder will get attracted towards the magnet and it would be difficult to remove these iron fillings. So not from the top, I'll be inserting this one from the bottom. Means that I'll be inserting this thing from the bottom. So I'll take the paper somewhat up and place the magnet like this, and now I'm going to gently keep it like this way, and now gently I'm going to tap on the white color paper like this. Right. So my dear children, you can observe a wonderful pattern. When you tap on this thing, you can observe a wonderful pattern. See the pattern, right? You can observe the pattern very clearly. And we can see that around this area, the iron powder is getting attracted towards the magnet. So around this area which the magnetic power is going to spread. So it is obvious to us that these iron fillings are getting attracted only in this area. It's because that within this area we can observe the magnetic power or the magnetism of this bar magnet. So this area which the magnetism or the magnetic power spreads is referred as the magnetic field. So it's clear to us that in a bar magnet, the magnetic field is going to spread like this, right? So this is how we can identify the magnetic field in a bar magnet by using this paper and the iron fillings. So you have to remember. So now if I'm going to take this away, so it's easy to identify the pattern. See, now the pattern is really simple to identify, and this is the area which the iron fillings are arranged to a pattern. So this is how to identify the magnetic field of a bar magnet. So let us carry out another experiment in identifying the magnetic field of a bar magnet, but not in a two-dimensional array, but in a three-dimensional array. Right, my dear children, now I'm going to do another activity in finding out the magnetic field. So in earlier activity, we found out the magnetic field just in a two-dimensional array. Means that I have arranged iron fillings on a certain white color paper, and I have put this bar magnet below it. Then I have tapped on the white color paper or the A4 sheet, and the iron powder on the A4 sheet arranged to a certain pattern, but in a two-dimensional array. Means that towards the length direction, or the in a length way, and to the breadth of the A4 sheet, and towards the length of the A4 sheet, iron powder arranged just in a two-dimensional way. So now I am going to show that the magnetic field of a magnet is not just going to arrange in a two-dimensional array, but it's going to arrange in three dimensions. Means that it is going to spread not lengthwise, not just the breadthwise, it also moves towards the height-wise as well. So let us engage in this activity to identify the three-dimensional array of the magnetic field. So I have a beaker of glycerine here, right? I have a beaker of glycerine here. So glycerine is a high viscous liquid, right? And it's like an oil. So now and I have a test tube. So I'm going to insert the magnet to the test tube like this, so that when I'm going to insert the magnet into my glycerine container, the iron powder inside the glycerine would not attract to this magnet. And I'm placing it like this, and now I'm going to insert the iron powder into this glycerine container. So let's insert this iron powder into the glycerine container like this. Right. Now I have a glass rod with me, so I can use this glass rod to shake this container so that the iron powder will spread along the liquid very well. So I'm going to spread it, and while I'm spreading it around the container, I'm going to insert the magnet. Right. So can you see there is a pattern? There is a pattern in around the magnet. We can observe a clear pattern around the magnet. The iron powder has arranged in all over the magnet in a circular way, not just in a length or breadthwise, but we can say that the magnetic power or the magnetism spreads in all three dimensions of a magnet. So the magnetic power spreads in all three dimensions of the magnet. So it is obvious to us that magnetic field or the magnetic power is not just a two-dimensional force or two-dimensional magnetic force, or the magnetism is not just two-dimensional, but it is spreading all around the magnet in a three-dimensional array. Right. So this is about the magnetic field then. We'll discuss further things related to the lesson in the next time periods. Okay. Right, my dear children. Now, in this activity, we'll be finding out how does the magnetic field lines are getting arranged around two magnets when like poles are placed and when unlike poles are placed each other. So in this situation, I'll be needing now in the activity, I think within the materials, we used a regiform sheet, but instead of a regiform sheet, I have used a sponge layer so that I can continue with the experiment quite easily. So I have used the regiform layer instead of I have used a sponge layer instead of a regiform. And instead of cardboard sheets, I have taken some A4 sheets like this. And once again, I have another two A4 sheets which applied with thin layer of glue, right? So this is to paste, or this is to copy down the pattern which is getting observed during the experiment, right? So I have already applied the glue. It's because that I need to keep it for some time so that the glue will get somewhat dried up. No, so I have already applied it on it, right? So now I'm going to keep it in this kind of a place, and now I'm going to do the activity. So our activity is really simple. How to conduct this activity then? So I have two magnets like this. First of all, I am going to place the two magnets so that the unlike poles are facing each other. So that the unlike poles are facing each other. So here the north pole is facing towards the south pole. Now I'm going to keep one A4 sheet like this at the top, and now I'm going to put some iron powder into it. So it's easy to do the experiment like this. I'm going to keep it away and I'm going to pour this iron powder into the A4 sheet like this. Then I'm going to spread it here and there. So I'm going to spread it here and there by using this glass stick. Alright. So I have spread it here and there by using this glass stick. And now what I'm going to do is, now I'm going to place it over the two magnets in here, and gently I'm going to take this thing and I'm going to place it over the setup which we arranged by using the magnets. Right. Now what I'm going to do is, I'm going to tap on the A4 sheet like this. So remember, my dear children, here we put unlike poles together. Here we put unlike poles together. Alright. Now we could get a certain pattern here. Now what I'm going to do is, I'm going to take one of the A4 sheets which I have applied with glue, and I'm going to paste it over this thing so that I get a good imprint. Okay, so I'll place it like this. And I'm going to take the imprint of the iron powder by pressing it downward. Right. Now gently I am going to remove. Right. So it's difficult to get off the paper as it got stuck with the glue. Right. So I'll remove this excess paper. Right. Now this is my imprint. See? Now this is my imprint. You can see a good pattern. Here you can see that the magnetic field lines of the two magnets. See? The magnetic field lines of the two magnets are facing each other. It's clear to us that the magnetic field lines are facing each other. You can clearly observe it. Observe the pattern, how the magnetic field lines are facing each other. So these are like poles. So we can name, I'll use a marker pen. I'll use a marker pen and name the north and the south pole of these two magnets. Or else you can use just a pen if you want, but it's quite good to use a marker pen. So I'll use a marker pen and use the north and south poles like this. So north and south poles, right? So here, now this is the pattern which we can observe. This is the pattern which we can observe when the unlike poles are kept near each other. So this pattern is quite obvious. You can observe that the magnetic field lines are getting attracted each other. So the magnetic field lines are attracted each other from north to south pole. And now let's see how does the magnetic field lines are getting arranged if I am going to place the north and south poles, not the north and south poles, but the like poles, north or south together. So I'll keep south and south together like this. And now I'm going to once again apply iron powder and again tap on it, then get the imprint onto another A4 sheet. So I can use the previous ones. So keep it in here. Use another paper. I told you that earlier, to conduct the activity quite easily, we can use 4 A4 sheets or else 2 cardboard sheets and 2 A4 sheets. But here I have used 4 A4 sheets. Right. Once again I am applying iron powder. And now I am spreading iron powder here and there by using that glass sheet. So I have this glass stripe. I'm going to spread all the iron powder here and there by using this glass strip. Right. Now my dear children, I am going to keep this thing over the setup that we arranged by using the two magnets and that sponge layer, right? So let's gently keep this A4 sheet over the system like this. Now I'm going to tap so that the magnetic field lines would arrange. Right. Now I'm going to take my second A4 sheet which I have applied with glue, and I'm going to place it like this and press so that the imprint is getting pasted on this A4 sheet. Right. Now I'm going to take it away. So I'll use it once again. Right, my dear children, now in this you can observe the magnetic field lines are facing away from each other, not like in the previous case where we did get an imprint. So I'll remove it and I'll show you the other one. So see, this one and this one, there is a clear difference. There is a clear difference between the arrangement of magnetic field lines. So here I have written it by using the marker pen. I have marked the poles. So here this one, you know, this is the south and south poles, this one. So here the magnetic field lines are facing away from each other. But in here the magnetic field lines are attracting each other. So it is obvious to us that magnetic field lines are getting spread around two magnets into a pattern like this. So this pattern is going to change when I am going to interchange the two poles of the magnet. Right, my dear children. Now in this activity, we will be discussing how to make a simple toy compass. Right. So you know that compass is a magnetic material, or else it has a magnet that pivoted around a certain structure so that it could freely rotate. That's how a magnet has been prepared. So I have also a magnet right here. So you can clearly observe this magnet. It's always pointing towards the north and south directions. See, you can see that the red color terminal is always pointing towards the north and the other terminal is pointing towards the south. So this is how a magnet works when it is rotated freely. So always it's going to suspend pointing north and south directions. So that's the principle that we are going to use in here, right? That's the principle when we are going when you are using in here in making this simple toy compass, right? So I'll keep the compass like this so that you can compare the directions of turning with the compass and the apparatus which we are going to prepare. So first of all, I'll be needing these materials. So I have organized these things, the materials which we need on this table. So here you'll be needing a bar magnet, a permanent magnet, right? Then a basket of water, a needle and a piece of cork. So first of all, I'm going to take the needle and I'm going to make a permanent magnet by using the contact method. So contact method, in doing the contact method, you have to apply. I'll take the water basket to somewhat different location. So first of all, you need to make a permanent magnet out of this needle. How to make the permanent magnet, my dear children? You have to rub the magnet against the needle but to a same direction by using the same pole. So I have used the north pole right now. Then I have to rub it against the needle like this. So always remember, you need to rub it against to the same direction. Don't rub here and there. If you are going to rub here and there, then the expected results will not be obtained. So you have to rub it against the same direction and also use the same pole. Don't change the poles. Use the same pole. Now here I have used the north pole. You have to always rub against the north pole then. Like this for some time. You have to gently rub the magnet against the needle onto a same direction. Now it's important to apply the magnetism for a somewhat longer time. Otherwise, we can't get the observations clearly. So we need to rub the magnet against the needle for some time. Right, now I have prepared my permanent magnet right now. So now you need to take this permanent magnet and insert it onto the cork like this. So I'm inserting it to the cork like this so that I can get two terminals. So this is the pointed terminal and this is the normal terminal. This is not that much point. This is the place where we insert the thread and this is the pointed terminal. So now I am going to take my water basket. Now I am going to take my water basket and now I am going to insert this apparatus into the water and see to which directions these 2 points are going to turn. So I have a compass with me. So check with those directions and compare the results. Okay. To compare the results, I have a compass near to me. Right. That's to compare the results that we are going to obtain from this experiment. So now I'm going to put this thing in the water. So we'll see to which direction does it rotate. So it's rotating now and it's going to suspend like this. See? So it's rotated and suspended like this. So you can see that not the pointed end but the other end is pointing towards the direction and that direction is same as the north direction of the compass. Here now I have used the compass to compare my results, whether I am getting a real compass or not. So actually this is a real compass right now. Always this point is going towards the north direction. Now if I am going to take this away from water once again and I am going to drop it. I'm going to turn it like this and I am going to drop it. So you can see that it is again turning and pointing towards the same direction. See? Again it is pointing the same direction. So the two terminals of the needle is always pointing towards the north and the south direction, same as the compass over here. So now I can take that red color paint, right? So if I want, I can take that red color paint and I can paint this end by using red color. So this end is the north pole, and this end, the other end is the south pole, right? So now I can take the red color paint and paint it then by that way I can use this apparatus as a simple compass to find out the directions. So this is the way of making a simple toy compass from these apparatus. So always we use the property in magnets. In any magnet, right, there is a special property. When we freely suspend a magnet in our environment, it's always going to turn to north and south directions. That's a property in magnets. Even the compass is also a magnet like that. Here we have suspended a magnet pivoted to a metallic or else a plastic structure. So the magnet would rotate and ultimately it would align along the north and south directions of the earth. So in the same way, when I have made a permanent magnet by using a needle and these simple instruments. Now the points or the terminals of this magnet is also pointing towards the north and south directions. So it is obvious to us that this apparatus or this instrument can be used as a simple compass. So we'll discuss further how to develop a simple toy compasses. Right, my dear children. Now let us discuss another different way of making a simple toy compass. Right. Now in this situation also we are suspending a permanent magnet. Right. We are suspending a permanent magnet freely so that it would rotate and turn to north and south directions. So to compare my observations, I have a compass right here, and also I have prepared a permanent magnet by using this needle. So you could remember that we used this permanent magnet and we rub it against the same direction like this, so that the needle would become a permanent magnet. So this method was called the contact method. So we use the contact method in making this permanent magnet. So I have prepared a permanent magnet by using the contact method, right? So now, and also I have this dried leaf. Right now, in the earlier case we used a cork to rotate the permanent magnet which we prepared by using the contact method, and now in this case we'll be using this dried leaf. So I'll put the permanent magnet which we prepared and we'll insert this thing in the water container to check whether it is getting turned towards the north or south direction or not. So I'll place it like this, and now it's getting rotated. I'll keep it in a different position. So it's getting rotated. You can see it is getting rotated, and now it stopped. See, it stopped. So here you can see that this end is showing the north direction same as the compass, and the other end is showing, I'm going to take it to the middle. If I told you in the earlier case also, we have to keep it in the middle, otherwise we have to keep it in the middle, or else this would, if it is going towards the edge, then the expected results would not be obtained. So here now I have placed it like this. So once again I'll take this leaf and place it so that you can get a clear observation. So I took it, I'm going to turn it to a different direction and place it like this. See? So always you can see that the needle is pointing towards that direction and this direction. So like in the compass, the compass is used to compare our results. So here also in the compass you can observe this terminal shows the north direction and the other shows the south. So here also this direction shows the north and the other one shows the south. So you can use once again the red color pen to color this terminal by using the red color. Then in that way we can use this simple apparatus as a simple toy compass to find out the directions. So let's discuss another activity on how to finding or how to make a simple toy compass. Right, my dear children, now this is the third activity that we are discussing in making a simple toy compass. Now you can see I have arranged my materials. So you can see instead of the needles, I have used several pins with different types of lengths. So I have used 2 pins. Now instead of the needles, I have used pins here. So here I have used 2 pins of the same length, and this is the other pin, a smaller one, which I am going to insert into this piece of clay. Now instead of that soap bar, I have used a small piece of clay to fix this pin on it. Okay, right. Now let us see how to conduct this activity. So in the earlier I told you that we need to cut a piece of paper to a shape an arrow. So I'll cut this into a shape of an arrow like this. Then right, then what I'm going to do is I'm going to fold this paper symmetrically like this to have 2 equal portions. So okay, now this is our paper, right? So you can see that there are 2 equal portions like this. So now what I'm going to do is I'm going to keep this thing and I'm going to take my bar magnet. You know that we need a bar magnet in this case, and I'm going to take one of these pins, and by using the contact method I'm going to make out a permanent magnet. So you know that always we need to rub this thing to the same direction like this. Rub against the same direction. Remember to rub against the same direction and not here and there also. Means that not here and there like this. You have to rub it against the same direction. And always use the same pole. Now here I am using the north pole to rub against the pointed head of the pin. Now insert this pointed head. So I am inserting this pointed head on this paper so that the pointed head would lie on the direction same as the point or the head of the arrow, right? So now I'm going to take the second pin, and once again I'm going to contact it by using the permanent magnet onto the same direction like this. See, and I'm inserting this pin to the other portion of the paper. Right. Right, my dear children. Now I am going to fold the paper once again to have two equal portions like this, and now I am going to take this smaller pin and insert on this piece of clay, and I am going to fix it. You can use the piece of soap as well, or else a bar of soap to place this needle. If you want, you can place the needle on a cake of soap as well, but here I have used a piece of clay. Right. Now I am going to place this instrument so that it would rotate freely, so that it would rotate and turn to a certain direction. Right. So here you can see that the head of the arrow is pointing towards the south direction. How can I say that? Because I have a compass here with me to get or to compare my observations. So you can see that this direction is the south direction, and the point which shows the red color area is the north direction. So back end of the arrow is facing towards the north in here. Right? So you can clearly observe this is my south direction. So I can use the red color paint now and paint this area by using red color. So by that way we can use this apparatus as a simple compass. So once again, to check the observations very clearly, so it's good to have our pointed area towards the north direction. No. So I'll interchange my needles like this. I'll interchange the needle terminals like this, so that we can take a good observation, so that we can turn our arrowhead towards the north direction. Right. So let's see whether the arrowhead is going to turn towards the north direction in this time. So I'm going to place my instrument and let's see whether the arrowhead is moving towards the north. So it's rotating. We'll see whether the arrowhead is going to move towards the north direction. No, not. Right, my dear children. Now you could see that now in our instrument the arrowhead is always pointing towards the north direction. I can check it by using my actual compass in here. See, the red color area is pointing towards the north, and also in my instrument which I have prepared, the pointed end of the arrow is always facing towards the north. So this apparatus can be used as a simple toy compass to find out the directions. So it means that this apparatus which we prepared is going to behave as a simple compass. Right? So here also we suspended a permanent magnet on a simple needle, so that it would rotate and turn towards the north and south directions. So this is the way of making simple toy compasses, right? So we'll discuss the further things with the lesson also then. So my dear children, we'll be discussing another activity in how to make a simple toy compass. So here now I have these items. So I told you that in the earlier case also we have to use a wooden bar or else a wooden stand like this when we are making or when we are doing experiments related to magnets. It's because that you know that magnets and steel or else if you take metals, they have magnetic properties. So there is a possibility that the magnet would attract towards the metal. So it's good to use a wooden stand like this. So I have freely suspended a magnet. So you can see the magnet I have freely suspended by using the thread. Now I'm going to give you a gentle push to here so that it would rotate. So while it is rotating, keep eye on this magnet, keep eye on this compass. So you can see the compass. So here the compass is showing north and south directions. You can see it. The red color terminal shows the north direction and the other shows the south direction. So I'll keep it. See, the red color terminal shows the north and the other terminal shows the south. So I'll keep it in the same way like this so that you can observe the results which we can get from this magnet. So still the magnet is rotating freely. So ultimately it would stop in a certain position, right? So we'll check in which kind of a position does the magnet is going to turn and align. Okay. So the two directions should be north and south directions. Always you know that when a magnet is hung freely, it's going to turn towards the north and south directions. Right. Right, my dear children. Now the magnet has stopped the rotation. So here now you can observe the north pole is facing toward that direction, and you could observe in the compass also. Right? The north pole is facing same as the north pole of the compass. North pole of this bar magnet is facing same as the north pole in this compass. Means that this magnet is always pointing. The north pole of this magnet is also always pointing towards the north direction of our earth. Means that this apparatus could be used as a simple toy compass to find out the directions in our day-to-day life, right? So this is another way of making a simple toy compass. Here we suspended a magnet, a permanent magnet, freely to rotate and to turn to desired directions. So we observed that the two terminals or the poles of this magnet would turn to north and south directions of our earth. The north pole is always pointing towards the north direction and the south pole is always pointing towards the south direction of our earth. So we'll discuss another method to make a simple toy compass in our next activity. Right, my dear children. Now in this activity, we'll be investigating to which kind of a direction or to which direction does this magnetic field lines going to turn, or onto what kind of a direction, to which kind of a direction does the magnetic field lines are arranged in a magnet. So to identify the direction of magnetic field lines, we'll be needing a compass. Now it's better to have several compasses, but so by that way you can keep all these compasses like 3 or 4 or 5. You can keep it in different positions and you can draw the directions. But if you can't find like several compasses, we can use just one single compass like this. And to draw out the direction of the compass or the direction of the needle which the compass is going to turn, I have some marker pens with me and a white color paper and A4 sheet to draw out the lines or the direction which the compass is going to turn. right? So first of all, I am going to place my magnet like this on the A4 sheet. So you can see that this is my north and this is my south. So I'll draw the position by using the marker pen, position of the magnet by using the marker pen. Okay. Then to identify the north direction, I'll use my red color marker, and this is the north then. This is the south pole. Right. Now once again, I'm going to place the, see, this is the north, this is the south. Then once again, I'm placing my magnet so that it would align in the same way as my north and south pole on the diagram. So now I am going to take the compass near to this north terminal, and I am going to draw the direction which the compass needle is going to turn. So let's see. To the north pole of the magnet, and by using the red color terminal, my dear children, by using the red color terminal, I am going to draw to which direction does the red color terminal turns. So when I am going to keep the compass in this position, you can see that the red color terminal is pointing away from, it's pointing away from the terminal, north terminal. So I'll draw it by using my blue color marker pen. So I'll remove it. Then this is the first position, facing away. Then I am going to place the compass in this position. So in this position, you can see that the red color terminal is facing to an angle to the initial direction, at an angle. So point in that direction. So we'll draw out that direction as well. Now I am going to keep it in here, the compass, and by using the red color terminal, I am going to draw out the position. See that? This direction. Okay. And once again, I am going to keep it in here. Right? I'll keep it in here. Can you see that? The terminal is pointing towards that direction. This direction. Then once again, I am going to keep it in here. And we'll wait. Right. Now the rotation of the compass has stopped. So I can point out the direction of the red color area. It points in that direction. So I'll mark it. And once again, I am going to use it in here, this position. Once again, it's somewhat rotating somewhat. We'll wait till the rotation stops. Right. So it has aligned towards the direction of the south pole. See? You can see it in here. The red color terminal is pointing towards the south pole. So like this. So I'm going to keep it in this position once again. And we'll wait. you can clearly observe that the red color terminal is directly pointing towards the south pole. So once again I am going to draw out the position. Then in here we have to wait till the rotation stops. So you can see that here also the red color terminal is pointing towards the south direction. So we'll draw out that thing also. So this is the pattern that we obtained when we are drawing. So I'm going to remove the magnet. So this is the pattern that we have obtained when we are drawing the structure or the arrangement of magnetic field lines. So it's obvious to us that magnetism spreads from north pole and it is going towards the, see, it's going towards the south pole like this. The magnetic field lines or the magnetism is going to spread from north pole and it is always pointing towards the south pole. So see, like this. So I can draw it like this. Always it is going to go like this. See? Can you see that? Right? So it's going to emit in this sort of a way, emit from north direction, and it's going to get collected at the south pole. Right? So it's obvious to us that according to this diagram, the magnetic field lines are spreading from north pole to south pole. Magnetic field lines are spreading from north pole to south pole. Always the magnetic field lines or the magnetic field spreads from north pole and it is getting collected on the south pole. So this is how the magnetic field lines are arranged in a magnet. It is always spreading from north pole to south pole. Right, my dear children. Now in this activity, we'll be investigating the factors which are essential for the turning of these magnets to a certain directions, in our earth. You know that a freely hung magnet is going to turn towards the north and south poles of our earth. So we'll be investigating why does a magnet is going to turn towards the north and south directions of the earth. Right. So to investigate this thing, I have used a magnet here. Now this magnet is hung freely, right? And I have two compasses. Now it's better to keep the two compasses like about 2 meters apart from each other. But in this situation, when comparing with the spacers, I have kept these two like about 1 meter of a distance, right? So it's all, if you want, you can keep the two compasses like 2 meters apart each other, right? That would be better to get some more accurate observations. So however, right, we'll be conducting by keeping like this way according to our spacers right here. So now let's see how to get some observation from this activity. Now I have a magnet here, you can see. So the north pole of this magnet is pointing in that direction, and also I have a compass here. So in this compass, you can see from this compass, right, these are the two compasses that I have. like 1 meter apart from each other, right? So this compass needle also showing that direction as the north, and this compass needle also showing that direction as the north. And also you can observe in here, right? Also you can observe in here, the north pole is directed towards the same direction as the compasses. Now I have a bar magnet. Now I am going to check what would happen if I am going to bring near this bar magnet near the hung magnet and also on the other two compasses. So we'll take the first compass. See, I'm not even taking it closer to the compass. You can see that the compass needle is turning when I'm turning this, right? When I'm turning this magnet here and there, just no need to keep that even near. See, if I'm going to take it near, then it is going to rotate heavily. So even if I'm going to turn it like this way, not even closer to the compass, even though it is not closer to the compass, see, the compass needle is going to rotate, right? So here you can observe it's getting attracted and the direction is going to change, right? Now I'm going to take away the magnet and observe what will happen. Once again it is pointing towards the, see, north direction. The red color area always pointing towards the north direction. Now I am going to take my bar magnet once again and I am going to bring it closer this hung magnet. See, can you observe the south pole of the bar magnet, which is hung, is coming towards this north pole. See, you can clearly observe this thing, right? Means that the direction is changing. So if I am going to turn, see, it would turn, see, and it will change the direction. Now I am going to freely suspend it once again and it would rotate, and ultimately once again it would align in the same direction as the like in the compasses, that those two directions are north and south, right, my dear children? Now you can observe that the magnet has stopped the rotation and it is pointing towards that direction, means the north. Here you can observe it by using the compass in here. See, the north direction. See, it's the north direction, right? And also you can see that this magnet is also pointing towards the north direction. Now I am going to take my magnet once again and I am going to point it towards the other compass and see whether the direction is changing. Of course the direction is changing. See, the direction is changing when I am going to turn the magnet. And also if I am going to keep it like in here, like in this kind of a place, see, you can observe this one is also going to change the direction, and as well as this one is also changing its course. See, can you see that? You can clearly observe. So I am going to place it like this way, right? I am facing the north pole like this, and you can observe that the south pole is attracted towards the north one, and this in this magnet also the south pole would attract towards the north pole. So we'll wait until the rotation is going to finish, right? So my dear children, to take the observations quite clearly, I have taken the magnet somewhat up so that the magnetic field of this magnet would directly affect the hung magnet. So you can clearly observe that this magnet is going to turn towards the direction or towards the magnetic field of this magnet. So if I am going to change it, see, it always attracts towards this magnet. So it is quite obvious to us that in this compass, the magnet which we hung and the other compass which is somewhat far away, all of these three instruments, the direction of these three instruments is going to affect when I am going to give an external magnetic force, or when I am taking this instrument near to a external magnetic field. Always this instrument would show the direction of the magnetic field which is located externally. You can see that if I am going to take the south pole of this one, then see, you can observe, I am not going to take somewhat closer to it, even though I am keeping it like this way. See, you can observe that the north pole is always showing the south pole of the magnet. And when I am going to take the compass also, when I am going to keep it near the compass also, it is also pointing towards the north pole of the compass, also pointing towards the south pole of this magnet. Now I am going to take it near to the second compass. So here to the second compass, see the rotation of the compass clearly. See, it's getting attracted towards the magnet. So this is the magnet and this is the north pole. It's getting attracted towards the magnet. So it is obvious to us that external magnetic field is the reason for this turning in each of these instruments. No matter whatever the compass, it's going to turn to the direction of a certain magnetic field, to an external magnetic field. So my dear children, I'm going to keep the magnet away. Now once again I am going to check to which kind of a direction does this going to turn, right? So we'll wait until the magnet is going to finish the rotation. Right, my dear children, then you can observe that once again all of these three instruments would align in north and south directions. It's because that we can conclude there is an external magnetic field around our earth. That's why these instruments are aligning towards the north and south directions. I told you that in the earlier case, these magnets, you know that the compasses are also made from magnets, right? So these magnets would turn to a certain direction or would turn away from a certain direction due to another magnetic field. So my dear children, this is the reason for the turning of each of these instruments. So these instruments or these magnets are turning always towards the north and south direction due to having a magnetic field around our earth. So finally we can say that our earth contains a certain magnetic field, and due to that magnetic field, when a magnet is freely hung on our environment, these magnets always going to turn towards the north and south directions. It's because that north and south directions are the ones which containing the magnetic poles of our earth. So those are the two directions which contains the magnetic poles of our earth. So this magnetic field around our earth is called as the geomagnetism. So due to this geomagnetism effect, the magnets, when they are freely pivoted or when they are freely hung, they would always turn towards the north and south direction. Right. So let's discuss further thing related with the geomagnetism then. So my dear children, now I have a copper wire like this. You can observe the copper wire like this. Now in this activity, by using this copper wire, we are going to make a temporary magnet, right? So temporary magnet is a magnet which the magnetic power or the magnetism is remain for a short time period. In a temporary magnet, the magnetism or the magnetic power is remain for a short time period. So by using this copper wire, this is an insulated copper wire. So by using this insulated copper wire, we are going to make this temporary magnet. So the instrument that we need given in here, will be needing several pins, a permanent magnet, an iron nail, some dry cells, and a switch and some connecting wires. So let's see how to make this temporary magnet. So first of all, you have to take this insulated copper wire or the copper string. Insulated means if you take the string, now you can see that this has a quite unique color. But when I am going to scrape it by using a small bit of a sandpaper, I am going to scrape it like this. So when I am going to scrape it down like this, you can observe two different colors. It's because that here you can now observe the original color of copper. See, it has a quite shine, like a good shine. You know that is referred as the metallic luster. So it has a good shine. So when you take the area like this, it doesn't show a shine like this because these areas are covered by an insulation, a plastic layer, right? So remember, when you are taking these insulated copper wires and when you are connecting it to a certain electric source, we have to scrape it by using a sandpaper or else by using a sharp instrument. We have to scrape it like this. Then after that only we need to connect it to an electric source. So in that way we could flow electricity, or we can allow to flow electricity through the copper wire. This is the one which is referred as the insulated copper wire or the copper string, right? So I'll be needing some dry cells. So I have used, see, I have used a case to apply or case to fix the two dry cells, and some connecting wires and some crocodile clips to hold the terminals. And also there is a switch so that I can connect and disconnect. And the main one is this iron nail. So we'll be needing an iron nail to wrap around the wrap the coil around it. Okay. So first step is to take this and you need to wrap this insulated copper wire around the iron nail like this. Wrap it like this. So if you can increase the number of turns which the coil is going to wrap around with the iron nail, in that case you can increase the magnetic power as well. So it's good to have good number of rotations or turns around the iron nail. Right. So I have wrapped the copper wire around the iron nail, and now I am going to take this iron nail near these pins. So you could observe that there is no magnetic power to attract these pins. These pins are not getting attracted to this iron nail. But when you take this bar magnet, and when I am going to take the bar magnet near these, here you can observe that the nails or the pins are getting attracted towards the magnet because the magnet has magnetic properties. But in this case, you could see clearly now there is no magnetic property in this magnet. Now what I am going to do is I am going to connect these two terminals. I have already scratched it, so I don't need to scratch it once again. I have already scratched it, right? So I'm going to connect these two terminals to the dry cells by using these crocodile pins, right? And now I'm going to turn the switch on, right? And I'm going to take near this iron nail. See, you can clearly observe that the iron nail can attract these pins. See, iron nails can attract these pins. Okay. So my dear children, now I am going to disconnect the current by removing this crocodile pin. So you can see that some iron nails are still getting attracted towards the iron nail. Some pins are getting still attracted towards the iron nail, right? See. Okay, once again I am connecting it. See, once again these pins are getting attracted towards the iron nail. So when I am going to kill the current, see, these pins will drop down. Now dear children, now there are some iron nails around, there are some small pins around the iron nail. It's because that when I am going to give the current, some amount of magnetic field is going to still stay along the iron nail. So that's why it's not getting fallen, right? So however, after some while, this iron nail will not have any magnetic properties. So you can see that now this iron nail do not have any magnetic properties. Means that only when providing current to the circuit like this, see, only when current is being provided, in that case only we can observe the magnetic field around the iron nail. Means that this is a setup, or this instrument is going to behave like a magnet, but this magnet is a temporary magnet. As we kill the current, the magnetism is going to disappear and the pins will fall down. Right, my dear children. Now in this activity we'll be discussing how to make a permanent magnet by using the electrical method. How we can make a permanent magnet by using the electrical method. So in this method, in making a permanent magnet, we'll be needing these materials. So a copper wire, right? A copper wire, then some pins, right? Some pins, an iron nail. So it's wise to use a smaller iron nail, because when you take a smaller iron nail, it's easy to embed the magnetic field quite easily, and it will take less time to embed the magnetic field if you use a smaller iron nail like this. And a cardboard sheet is the one which we need, but it's difficult to wrap the coil around a cardboard sheet. So I have used here a PVC piece of PVC pipe. so that I can wind this copper coil quite easily around the PVC pipe. So it's okay to use a cardboard one as well, but still it would be difficult to wrap the coil, because the cardboard sheet may get bent here and there. Okay, and some connecting wires, right, and a dry cell. So this is a 9-volt dry cell, so it's good to use a more powerful dry cell in this situation or in this activity, so we could get our necessary observations quite easily and quickly. So first of all, I'm going to show you that when I'm going to take this iron nail and I'm going to direct it toward these small pins. So you can see that there is no such attraction between the pins and the iron nail, the smaller iron nail that I have in my hand, right? It's because that this one is not showing any magnetism, means that this iron nail do not show any magnetism and it doesn't carry any magnetic power. So you can see it obviously, you can see it very clearly. It doesn't show any magnetism or magnetic field. There is no magnetic field around it, and it is not getting attracted. The pins are not getting attracted towards this iron nail, right? So now what I'm going to do is I'm going to take this PVC cover, and once again, like in the earlier activity where we wrapped the coil around the nail, in the same way we are wrapping this coil around the PVC covering like this. So always remember, in the earlier activity also I told you this thing, these wires, these copper strings or copper wires are insulated. So when you are going to connect these to an electric source, remember to clean the two edges by using a sharp material, or else you can use a piece of sandpaper as well, right? So we'll wrap the coil around it, right? Okay, right children, so now I have wrapped the coil around it, but you can see that the coil is getting escaped from the PVC. So what I'm going to do is I'm going to give out a bend so that it won't escape. Okay, right. So now I have prepared my coil. Once again, I'm going to show you that this iron nail do not show any attractions with the pins in here. Okay, see, doesn't show any attraction. And now I'm going to insert this into the PVC tube like this and keep it in a steady position. And I'm going to take my dry cell and connect the dry cell to the coil like this. So we'll use the wires and we'll connect the two terminals. Right. Now let some time to pass by and we'll observe whether the iron nail, that small iron nail, has got the magnetism or not. Right, my dear children, now I have waited for some time. Now let's see. Now let's disconnect the circuit and let's see whether the pins are getting attracted to this iron nail or not. Now you can clearly observe that there are some pins which are getting attracted to the iron nail, and these pins are even not getting fallen down. See, these pins are getting strongly attracted towards my smaller iron nail. See, you can clearly observe the iron nails are getting attracted. These smaller pins are getting attracted towards the iron nail. So that means now in the earlier case, which I have used just the iron nail without inserting it into this system, right? Without inserting into this system, I have just shown you how it is going to behave. So it doesn't going to attract any pins in the earlier case, but now you can clearly observe. Now you can clearly observe this iron nail can attract several pins from the system over here. So means that this iron nail is behaving as a permanent magnet right now. So this is the way of creating a permanent magnet by using the electrical method. So we'll discuss another method in making a permanent magnet, right, when we go with the further things with the lesson. Right, children, now in this activity we'll be discussing how to make a permanent magnet by using the contact method. How to make a permanent magnet by using the contact method. Now in the earlier activity we discussed how to make a permanent magnet by using the electrical method. Now here we are using the contact method to make a permanent magnet. So you could remember when we are making a simple toy compasses, right, we use this contact method in making a permanent magnet. So in the same way, what you have to do, you have to take a needle, right? You have to take a needle. So first of all, I am going to show you that this needle doesn't show any magnetic properties. So I am going to take it near some pins like this, and you can see that the needle doesn't show any magnetic properties. It can't attract any pins. See, it can't attract any pins. So it doesn't show any magnetic properties. See, those things are not getting attracted. So now what I'm going to do is, I'm going to take the permanent magnet and I'm going to place it like this kind of a position, and now I'm going to contact or rub the magnet to a same direction by using a same pole like this continuously for some time. Always remember, the longer you are doing this thing, then you will be making a more powerful magnet, and the number of times you are doing this, then you are making a more powerful magnet. If you are making if you are turning or if you are rubbing this magnet against the needle for longer time period or in more number of times, in both of the situations you can create a more powerful magnet. So I'm going to rub it like this. Now let's see whether the needle can attract these pins right now. Now you can see that the needle is getting attracted to these pins. See, you can see that large number of pins are getting attracted to this needle head. See, so even I am going to shake this thing, right? Even I am going to shake this thing, but still those pins going to hold with the needle. It's because that now the needle is behaving as a permanent magnet. So in the earlier case, needle haven't got any ability to attract these pins, right? You could observe it doesn't show any attraction with the pins. but now it's directly getting attracted, and quite easily it is getting attracted, and also you can see that large number of pins are also getting attracted to the needle. So means that this needle is behaving as a permanent magnet. So this is the way of creating or building up a permanent magnet by using the contact method. So you have to remember these two things when you are making a permanent magnet by using the contact method. Always use the same direction to rub the magnet against the needle, and always use the same pole in rubbing it. And the other thing is that if you want, you can increase the number of times which the magnet is going to contact with the needle, and or else if you have enough time, or you can apply, or you can rub the magnet for a longer time period with the needle, right? It's important to do those two. It's because that when you are rubbing it against more and more with the magnet, so you can get more magnetic power, right? So this is how to make a permanent magnet by using the contact method, right, my dear children? Now let's see the next activity to check how the magnetism is going to deplete in a permanent magnet. So once again, I have a different permanent magnet here with me, right? So now I'm going to take this magnet towards the pins, and I'm going to show you that this magnet can attract large number of pins towards it. See, it can attract several pins, means that there is magnetism. It can attract several pins, means that there is magnetism on this magnet, right? Okay children, now I'm going to drop these things down. So I have some powerful magnets with me right now. So I told you in the earlier situation a few while ago, I told you that these magnets are made from ferrite, right? And these are more powerful magnets. These magnets are made from ferrite, and these are more powerful magnets. That's why they are black in color. This ferrite material is black in color, iron oxide, right? So these are more powerful magnets, right? These are more powerful magnets. Now what I'm going to do is, I'm going to keep this magnet in a position like this, and I'm going to keep the other magnet over it like this, right? And I'm going to keep it for some time, and to check whether the magnetism is going to deplete or not after it has been subjected to high magnetic field, right? So I'll keep it like this way. I'll give some time for the apparatus, right? Then we'll check whether the magnet can attract these pins or not. Right, now I have placed the apparatus for some time. Now I'm going to take this. Now let's see whether this magnet can attract these pins or not. So once again, you can observe that none of the pins are getting attracted towards the magnet in here. The attraction is very less. Now in the earlier situation, you can observe that large number of pins or more number of pins were attracted. But in this case, see, we can't observe. Not even a slight attraction couldn't be observed. See, not even a slight attraction. Not even a slight attraction. So this permanent magnet has depleted the magnetism or the magnetic power because it was subjected to a high magnetic field given by these ferrite magnets. So we can finally conclude that the magnetism of a magnet can be depleted due to, or we can deplete the magnetism or else the magnetic field of a permanent magnet by subjecting the magnet to a higher magnetic field, right? So these are the ways of depleting magnetic field in a permanent magnet. When a magnet is being hammered, or we can say that when a magnet is being subjected to greater vibrations, right? When a magnet is being subjected to greater vibrations, the magnetism is going to deplete. And when it is being subjected to a greater heat energy, or if you are going to heat up the magnet, in that kind of a situation also, the magnetism or the magnetic field will lose from it, right? And the third condition is when the magnet is being subjected to a higher magnetic field, a stronger magnetic field, in that kind of a situation also, the magnetic power is going to lost. So these are the ways, the main ways of depleting the magnetic field. But there is another way. Now when you take these magnets, especially steel magnets, if you are going to use it for a longer time period, if you take a steel magnet like this and if you are going to use it for a longer time period, like in years, right? Not for a day or two, but for years. Now in that kind of a case also, the magnetism would reduce. It's because that when a magnet is going to age, or when time is going to pass by and a magnet is going to age, not in days or months, but in years. Like that kind of a case also, the magnetism would reduce in a permanent magnet. So there are 4 factors which can deplete the magnetism of a magnet. So those factors are aging. Aging means when the time is going to pass by, the magnetism is going to reduce. And the second one, when a magnet is being subjected to vibrations, or when you hammer it, or if you drop down a magnet several times to the ground, then in that kind of a situation also magnetism would deplete. And the third case, if you heat up a magnet, or when a magnet is subjected to a greater heat energy, right? In that kind of a situation also the magnetism would reduce. And if a magnet is being subjected to a greater magnetic field, in that situation also we can observe the magnetism would deplete. So these are the ways of depleting magnetic field or the magnetism in a permanent magnet. Right, my dear children. Now in this activity we'll be discussing, if I'm going to take a permanent magnet like this, what are the possible ways of depleting magnetic power or the magnetism in this permanent magnet? So, to investigate the methods of depleting magnetic power of a permanent magnet, we'll be using different types of methods, right? First of all, I'm going to use this hammer and I'm going to hammer on the permanent magnet and to see whether how much of pins are going to attract. So here I'll be mentioning less or more, the attraction of pins less or more when it is being hammered, or when after it is being hammered and before it is being hammered. And once again I'm going to use this spirit lamp and I'm going to heat up this permanent magnet and to check how much of pins are getting attracted to the magnet before and after the burning process or the heating process. Then I have some magnets. See, these magnets are very strong. These magnets are very strong. If you take this magnet, right, in this magnet you can see there is some bit of a shine, right? There's a bit of a shine in here, right? It's because that this is made up with steel, There's a bit of a shine in here, in this edge, right? It's because that it is made up with steel. I can show it to you by scratching it by using a piece of sandpaper. Right. Now, see, you can clearly observe there is a shine. It's because that this magnet is made by steel. So rather than the steel magnets, if you take these black color magnets, these are black in color. No matter when you scratch this thing, right, we can't see any shine. See, we can't see any shine. It's black in color. Even you can see the stains on my finger as well. See, it's black in color, right? Means that this is made up with ferrite. You know that ferrite is a good magnetic material and it is being used to make permanent magnets, right? So this is ferrite or iron oxide, a good alloy to make permanent magnet, right? So these magnets are very strong. So now in the third case, I am going to subject this permanent magnet, which is made up with steel, to this strong magnetic field, and I am going to observe how much of pins is getting attracted to the magnet before and after subject it into a higher magnetic field. Now let's conduct the activity and see whether by using these ways whether we can fade off the magnetic field of this permanent magnet or not. So first of all, I am going to show you that this magnet has a certain magnetic effect or magnetic power. So when I am going to take, see, when I am going to take this thing, you can observe several pins are getting attracted. See, you can observe large number of pins are getting, or more number of pins are getting attracted in this case. So now what I am going to do is, I am going to take a wooden stripe and I am going to hammer it well. And to observe whether these things are getting attracted to the magnet or not. So you can see that even though I am going to keep near the magnet, just only a one pin is getting attracted. Now that one also fell down. See, it can't attract the pins. Just a one single pin is getting attracted at just at the end, right? So here we can say that after I have hammered, very less number of pins are getting attracted to the magnet, and before hammering, large number of pins were attracted, or more number of pins were attracted, right? Right. So you can observe that this magnet can't attract any pins. So you can see that once again, this magnet can't attract any pins. Just a one single pin is getting attracted, but it is also getting slightly attracted. See, it is getting slightly attracted, right? Very slightly attracted. It's because that after hammering, the magnetic effect or the magnetism has been depleted from the magnet, from this permanent magnet. So now we'll have to use a different magnet once again. We have to use a different magnet once again to find out the other effects or other ways of depleting magnetism. Right, my dear children? Now I have taken another separate magnet. So I'm going to show you that this magnet has some magnetic effect. See, it can attract several number of pins. Large number of pins are getting attracted to this magnet. You can observe it clearly. And now what I'm going to do is I'm going to take this spirit lamp, right? And now I'm going to light up the spirit lamp. Okay, so I have light up the spirit lamp, and now I am going to burn or heat up this magnet, right? And to check whether it is getting attracted or not, right? We'll heat up then. Right, so we need to heat up this thing like this. And now let's see whether this magnet can attract the pins or not. Okay. So here you can see that after the magnet has got heated, it can't attract any of these pins. Just one, but it's also slightly. See, difficult to attract just one piece of pin. It partially getting attracted and once again it's falling down. See, so here partially you can see that partially getting attracted. Now you can observe just one single piece of now once again it fell down. So you can see that after this has got heated, the magnetic power has reduced or the magnetic power has been fade off. So you can say that when the magnets are subjected to heat energy, the magnetism is going to deplete or the magnetic power is going to reduce. Now we have to throw away this magnet also. So most of the times when we are conducting these experiments related to depletion of magnetism, we'll be using some older magnets, because after destroying the magnetism, there is no use of these magnets. So I have to throw it away, right? So we'll use a different magnet and we'll conduct another experiment to check how the magnetism is getting depleted in a permanent magnet.